We talk a lot about consumer friction and frustration consumers have in their daily experiences in shopping. For me, one of them is it's clear retailers would love to use more self checkout. Consumers perceive self checkout as a way to get through the line faster and reduce their friction. But one of the problems, and I have this, is often you've got to enter codes for produce and things like that. And I personally, I skip self checkout whenever I got to enter a code in. I'm just too lazy. My attitude is the retailer ought to do that for me. I'd like to introduce Offrey today from Edgify, and they've got some really interesting technology that enables a retailer to scale an easy to use solution without rip and replacing hardware. So Offrey, can you tell us a bit about what you're doing?
Sure. Thanks. So we've built a framework that can be integrated into the existing hardware and software that the retailers have that trains the AI models directly on those self-checkouts and lane pauses to create local AI training where you don't need to start investing in new infrastructure, cloud architecture, but your checkouts, they learn on their own to recognize and identify produce as it's being purchased by your shoppers, and then use it for prediction on those checkouts. So when you come as a customer and your biggest pet peeve is looking for the actual item in the screen, all you have to do is place the produce or product on the checkout, and the camera will identify it on its own.
So no data is going to have to move off site. You won't really experience big cloud charges or things like that.
Exactly. The whole notion here is a complete edge framework. So our it's all integrated into your existing checkout. If it's your self checkout, your smart scales, your lane pause, and they run all the training, retraining, and prediction capabilities locally. So each device, each checkout trains on its own data that it generates, and then shares the learnings with the other checkouts in the store or between sites, so that at each given moment, all the checkout systems have the most robust and accurate model for recognizing items. No cloud, no servers.
Well, one of the concerns I think retailers would have is it sounds like that could really result in some really heavy integration with their ISVs. How have you tried to address that?
So we created a very thin layer that just comes on top of the existing software. Really, all we have for the integration is two APIs. One of them is to get our prediction of what we think the product is for the retailer, for the software checkout software. And the other one is set ground truth, which just requires us to receive the code or the SKU of the product that's been placed for the training part of the process. And we actually, because of COVID, created a very easy process, all documented, self-integration, and are keeping a scoreboard, leaderboard for software systems that integrate our software the fastest. And we're down to about 5-hour integration of our system into an existing software.
You must be using really modern architecture, software architecture, then if you can do that. Can you say any more about the approach?
Yes, it's all Docker containers, all wrapped up together. One installation, you get the hub key from us, and you see all your edge devices show up on your screen, and they each run their own training. Because all the work is local, there's no need here for a massive consolidated framework that needs to be integrated into all the machines simultaneously and be connected. And so it's a very easy integration process that can happen quite quick.
Well, one of the other things that I love about what you're doing, at least in the examples of produce, your training cycle is actually you're training off to how the consumers are having their products weighed and scanned already. Can you talk a bit about that?
Sure. So the common methods that are the only way today to train AI, if you wanted to train an AI for a retailer to recognize produce, is to bring somebody to take pictures, I don't know, download photos from the internet. Let's take tomatoes, okay? You'll need to collect about, thousands of photos of tomatoes in different angles, shapes, sizes, and lighting, and then upload all that data to the cloud, to your server, then send that data set to usually Southeast Asia for a company to sit down and label each photo with a square around the tomato and write tomato, and send all that label data back to you. You run the training on it, and then take the model that you have, deploy it in the store, and then repeat that process every time there's a new batch of tomatoes that comes out that looks a bit different. And what we've done is the Edge framework replaces that entire process by saying, okay, your customers are going to come in. There's going to be a simple USB camera on the checkout. the first day they come in, they'll take the tomato, they'll put the tomato on the scale. The camera will take the picture of the tomato, snap the photo, and then they'll just do what they normally do, which is go to menu, vegetables, seasonal, tomatoes. And as soon as they've clicked tomatoes, what we've got here is that entire initial process I spoke about has just shrunk to one customer doing their shopping, because we have the image, we have the label, because they told us what it is by buying it. And now that machine, that computer has the image, the label, and enough compute power using our framework to also train itself on how to identify. So it's telling itself, okay, I've seen the tomato, I've been told it's a tomato, now I can start building that model locally. And if one machine sees one item, a different machine sees another item, at the end of the day, they all collaborate their models, so that if a machine only saw tomatoes for an entire day and one machine saw bananas for the entire day, at the end of the day, they'll both have a model that knows how to identify all the produce in the store.
This really addresses one of the big pain points for a retailer. They've got a bunch of capital deployed at the edge. They can't really afford to rip it out and replace it. It may have depreciation years still sitting on that hardware. Another piece of this is scariness of training and AI. I think you guys, it sounds like you really have addressed that. Maybe the last piece is, what do the numbers look like? What kind of costs are they going to incur giving this better consumer service? Is there any savings that they're going to see?
That's a good question. I think the cost comes from, when you talk about AI, most of the time you don't think about it as a cost. I think the biggest cost in AI is the accuracy of the model, because you can invest a ton of money in AI and come out short on the accuracy of the model, and then that money is not well spent. But if we think about today with AI, you look at companies like Amazon Go, and the bigger players. If you're thinking about AI as a retailer, you're thinking, I need a server room, I need a cloud architecture, I need upload and download speeds, I need a server room in the back of the store just to operate and maintain all my new AI innovation infrastructure. And that's where the cost goes usually in operating that. When you're doing an integration and using your own hardware, you don't need to upgrade your hardware. You don't need to build. You don't need to ask your local store down the street to now invest in a server room with cooling agents, and you need a special temperature control for your servers so nothing crashes and burns the store. And that's where the big savings are. And at the end of the day, when you're training locally, the accuracies go up as well. Right. So today, training at the edge, Edgify hits a 99.9% accuracy on prediction.
Wow.
Right. We think today the market average is about 68%. And that's not because our model our model architecture is better. It's because we train continuously on every new product that's generated without needing to think about how much money is it going to cost me to transfer this data to the cloud, label it, bring it back. Just for an anecdote, I mean, today to transfer an exabyte of data, which is what Walmart generates every 2 weeks, to transfer an exabyte of data to the cloud will take you 26 years using common methods. Now, that means you're obviously not going to transfer the exabyte. You're going to transfer maybe 0.01% of the data you generate. And an AI model is only as good as the data it's trained on. And as soon as you start restricting your data, you're going to restrict the accuracy of your models. So that's where the cost comes from.
Yeah, brilliant. Thanks so much for your time today. Edgify, really brilliant solution in simplifying for retailers. Thanks for your time.
Absolutely. Pleasure. Thank you.